Hello and welcome to another mathematics lesson. My name is Kingsley Linus. In today's lesson, we'll be looking at the need for statistics part 3. By the end of this lesson, you should be able to apply probability in everyday life. Secondly, you should be able to state the usefulness of statistics for prediction purposes. Recall that in our previous lesson, we established that in statistics, we collect and interpret data. Now, this data can be used for decision making, for planning, for the purpose of analysis, and for prediction. In this lesson, we'll be considering prediction purposes. Let's go ahead to learn some more about using data for the purpose of prediction. Before we see what prediction is, there is an important term we need to know about, and that is probability. Simply put, another word to replace probability is likelihood. You can also say chance. As humans, we have certain occurrences that happen around us. Some we have control over, while others we have little or no control over. For example, when you toss a die, whatever outcome you will have is not left at your control. This is what probability is about. Let's learn some more about probability. By definition, probability can be said to be how likely or unlikely something is to happen. It has to do with chance. For example, if we have a coin and we toss the coin, a coin has two sides or two faces. Now we can choose to call one of the face the head and the other face a tail. Now when that coin is tossed, definitely one of the faces will land. It's either the head or the tail. So when a coin is tossed, it's either we have a head or a tail. So the likelihood of having a head is 1 out of 2. The likelihood of also having a tail is 1 out of 2. Now, theoretically, let's see what probability is. Probability is given as number of ways a desired event can occur over total number of possible outcomes. So for a tossed coin, we can have only one face landing. So we have 1. All over the fact that we can have either a head or a tail landing. That is 2 options. So we have 2. So the probability of a head landing is 1 over 2. As well, the probability of a tail landing is 1 over 2. Now let's look at another example to illustrate probability. I believe you know a dice. When we toss a dice, we can have 6 different outcomes. Therefore, the probability of getting a 5 is 1 over 6. So, this can be interpreted as 1 to mean the number of desired outcomes and then 6 as the total possible outcomes. It is important to note that in probability, everything we'll be talking about is between certainty and uncertainty. We can assign 1 to certainty and a 0 to uncertainty. Every problem you ever solve in a probability question lies between 0 and 1. Now, the likelihood of getting any of the numbers on a dice is 1 out of 6. That is an unlikely event. We can't tell exactly what we might likely have. And then the chances of having a head or a tail when we toss a coin is 1 over 2. And that can be given as 0.5. Now, in a situation where we have 10 fruits, as you can see, and 8 of these fruits are oranges, while 2 are apples, you realize that the likelihood of picking an orange among these 10 fruits is 8/10. Now, 8/10 can be reduced to, we can have 8 divided by 2, that gives us 4, and 10 divided by 2 gives us 5. So the likelihood of picking an orange is 4/5. So note that probability only guides. Let's go on to learn about the usefulness of statistics for prediction. Statistics can be used for making sales projections, financial analysis of capital expenditure projects, constructing profit projections for a new product, setting up production quantities, and making sample analysis to determine the quality of a product. Apart from this usefulness I just mentioned, predicting can be used for gambling or betting. Let's go further in this lesson to learn some more about the usefulness of statistics for predicting. By prediction, we can actually create a mental picture of events to come, and this can help us plan accordingly. Let's see some tools that can enable us carry out prediction effectively. We have tools like charts, tables, and so on. They help us to avoid errors and bias, and we can achieve accuracy and precision using these tools. Let us look at an example. The table below shows the number of vehicles stopped for checking at a police checkpoint on the Port Harcourt-Owerri Express Road in a given week. A. Which day of the week was the highest number of vehicles checked? B. Which day of the week was the least number of vehicles checked? From the table, you can see that 450 is the highest number we have, and 230 is the lowest number we have. So, on Saturday, more vehicles were checked, while on Sunday, we have the least record of vehicles checked. Let us look at another example. The table below shows the number of recorded births in a community over a duration of 10 years. If we assume death was minimal, what predictions can be made from this information? You can see our table that shows us the record of births in several years over a 10-year duration. Now, from this table, we can make the following predictions. First, population is on a steady growth. Secondly, you realize that within a space of 10 years, the rate of growth of the population is almost 100%. You can see we have 400 here, and then we have 800. And lastly, we can say that in the nearest future, there will be a need for more resources to cater for the increasing population. Having looked at this example, I have a question for you. I'd like you to pause the video and try out the question. I'm sure you are done. The table shows the statistics of the team. A green means win, a red means loss. Now, question A says, from your observation of the data presented, does the team win more? The answer is yes, because the team had 6 wins out of 10 seasons. Question B says, what is the probability of the team winning a match? Based on information provided, you realize that they have 6 wins out of 10. So, the probability of winning a match is 6 divided by 2 is 3, and then 10 divided by 2 is 5. So, the probability of winning a match for this team is 3/5. Question C says, what prediction can be made about this team's performance for the next decade? We can simply say based on their previous performance that in the next decade they will have more wins. And lastly, question D says, what is the likelihood of the team losing a match? Now, from our records, we have 4 losses out of 10 seasons. That is 4/10. And we can reduce this to 2 and 5. So, our probability or the likelihood of the team losing a match is 2/5. If these were your answers, you are correct. Having had this exercise, we have come to the end of this lesson. But let's look at all we've learned in a summary. First, we learned that statistics is the practice of the science of collecting, organizing, presenting, and analyzing numerical data in large quantities for specific purpose. Secondly, we learned that the prediction of events using data collated and analyzed can enable us project into the future and make adequate plans before time. And lastly, we learned that probability tells us how likely something is going to happen or the chance that an event will or will not take place. I'm sure your learning was fun. How about trying some test questions yourself? Question 1. The probability of rainfall on a Tuesday when it is a rainy season is option A, 1, option B, 0, option C, 1/2, option D, 2/1. The correct answer is option C, 1/2. Lastly, question 2. The following can be achieved by predicting statistically except A, planning ahead, B, sales projections, C, likelihood of the occurrence of an event, or D, uncertainty. The correct answer is option D, uncertainty. Thank you for your time. This is where we come to the end of this lesson. See you again in another interesting mathematics lesson. Bye-bye.